again. I am the coordinator of the PlastiSea project, which is funded by the BlueBio program. Like Martin said, this is about producing bioplastics from seaweed, and this is particularly brown algae that we are talking about, since we've already talked about red algae. So just to give a little bit of a background, I don't think I need to tell anyone here that we have a huge problem with plastic pollution, and also that basically all of the plastics that is produced today comes from non-renewable fossil resources. A lot of the plastics that are produced end up as pollution, and most of this ends up at some point in the oceans. And quite a very small amount is actually bioplastics, which are defined as being bio-based and or biodegradable. But we also see that a lot of these bioplastics have issues, either with respect to sustainability or technical properties. So when we applied for this, when we were writing the proposal, that was also around the same time that there was this ban in the EU of single-use plastics. So the timing was really nice to start looking at other good sources of bioplastics. So of course we want to focus here on the types of plastics that don't end up in the recycling stream. So we really need to look at biodegradable and compostable options. So the consortium, the project is coordinated by SINTEF. Here you can see the other partners. I can mention that we have 2 industry partners in the project representing each side of the value chain. So we have a seaweed cultivator, which is Seaweed Solutions. And we also have Bizeos, which is a startup in Norway that are focusing on making bioplastic solutions from seaweed. So of course, a important question to begin with is why use seaweed for bioplastics? First of all, it's a renewable and quite resilient marine biomass. We already know that we need to use the oceans more, and we also have the potential of cultivating a lot more seaweed than is used today. And we still also have underutilized sources of wild seaweed that could be used for large scale applications. But if you look at the technical side, we know that the seaweed has structural biopolymers that we can extract and potentially use in bioplastics. And the most important one is alginate, which is a polysaccharide that can be cross-linked by divalent ions, usually used as a viscosity modifier or a gelling agent in food and other technical applications. And the brown algae also has cellulose, which is a little bit in lower quantities and also a little lesser known polymer when we're talking about seaweed. So in terms of biomass supply, you have, of course, wild harvested seaweed and also cultivated seaweed. So some facts about the wild harvest. This is what is used for commercial alginate production today. In Europe, there's around 0.3, 0.4 million tons that are being harvested. A lot of this is in Norway, and it's mainly used for alginate production. But the problem is that we can't really use too much of this wild biomass for bioplastics, because first of all, you have competing markets that are willing to pay a lot more for the alginate than a bioplastic producer can. But it's also an issue with sustainability and availability. So if you look at this, I mentioned that we have 400 million tons of plastics being produced every year. If we take 1% of these and say that these are bioplastics, and if we take another 1% of the bioplastics to make seaweed-based bioplastics, you would still need more than this 0.3 million tons to meet the demand for this bioplastics. So we need more sustainable sources. So cultivated seaweed.
Yeah, time is almost up. So.
Oh, I thought it was 10 minutes. Oh, I'm sorry. Okay, I guess I have to rush through a little bit. let's skip ahead a little bit. So they're just saying a little bit, comparing a little bit about the sources. I guess I'll have to come back, but to say something about the work in PlastiSea, we are currently working on new methods for conserving the biomass, so that we can prolong the harvest window and stabilize it, and see that this doesn't affect the quality of the biopolymers that we want to take out. We're also looking at ways to optimize the alginate extraction, looking at different mechanical, chemical treatments, how to get the most out of the biomass and also use side streams. And of course, also to see how much we need to process and refine these biopolymers to make good enough bioplastics without having a very expensive and time-consuming process. So for the product development, we are looking at different types of single use, not the bottles. It's more about the labels of the bottles, but also vacuum packaging and also like single use packages for food and other applications. And this is of course also important to see that these prototypes that we are developing are scalable and can be taken into a pilot and eventually industry scale. So just a little bit about the feasibility and market aspects. Of course, we need to look at sustainability compared to existing bioplastic solutions through a life cycle assessment. It's important that the biomass production scale is also reliant on market size. You need to have a large market to also scale up the production, which is quite small at the moment. Technology development is necessary to make better products, better cultivation methods, better processing methods. And we will also depend on getting these seaweed-based bioplastics to the market. We would be dependent on catering to high-cost markets, and also that you have some regulation on conventional plastics, such as the plastics ban, and you have increased CO2 taxing, etc. Yeah, so I'm sorry, I really thought there was more time, but if anything, if there are some questions, I can come back and answer in more detail.